When you hit send on a Pi transaction, you're doing way more than just moving a number from one wallet to another. You're actually creating a permanent, detailed digital story and carving it right into the blockchain. So today, we're going to dissect that story piece by piece to really understand what's happening under the hood. We're basically going to peel this transaction back like an onion. We'll start with the stuff you'd recognize, the who and the what, and then we'll dig deeper and deeper into the technical core that makes it all possible. So let's jump right in with the basics. All right, first up, the most fundamental question for any transaction, right? Who's involved? It's really just the digital version of answering who paid whom. So on the screen, you see the two key players. You've got the sender, or what the system calls the source account, and then the receiver, the destination account. But hang on, if you look closely at that destination address, you might notice something a little different. See that extra bit on the end? That is not a typo. It's actually a really clever feature. It's called a muxed address. And what it does is pretty cool. Instead of needing two separate fields for, say, an address and then an ID, it just cleverly packs them both into one. Now, on its own, this saves a teeny tiny bit of space, but when you multiply that by millions and millions of transactions, it adds up to a massive saving in data across the whole blockchain. Super efficient. Okay, so we know who's involved. Now for the fun part. Let's follow the money. We're diving into the financial data to see what the numbers really tell us. In your wallet, you'd see this nice, clean number, 199.99 Pi. Super simple, easy to read, makes perfect sense to us humans. But here's the thing. This is just the user-friendly version. It's not what the blockchain is actually recording. Not even close. This is what the blockchain sees. To make sure everything is absolutely precise and to avoid any weird issues with decimal points, the network operates in its smallest possible unit, which is called a stroop. Get this, one single Pi is equal to 10 million stroops. So that simple 199.99 Pi transaction is actually recorded as this absolutely massive number, almost 2 billion stroops. So this table gives us the whole financial picture in one spot. We've got the amount, we've got the asset type, native is just a fancy way of saying it's Pi, and then there's the network fee. And take a look at that fee, just 0.01 Pi. That is the small, fixed price you pay to have your transaction secured and recorded on this unchangeable ledger forever. All right, time to roll up our sleeves and get our hands a little dirty. We are now going into the absolute core of the transaction, what you could call its digital DNA. This is the raw data that gets permanently baked into the blockchain. Now, I know what you're thinking. This string of letters and numbers, the envelope XDR, looks like a cat just walked across a keyboard. But believe it or not, this chunk of what looks like gibberish is the single most important part of the entire transaction. It's a super compressed package that holds all the essential details we've been talking about, and a few more. So what's actually hiding inside that cryptic code? Well, it's pretty much everything. You've got the full addresses, the exact amount in stroops, any memo data you included, and even some technical stuff like time limits for when the transaction is valid. The XDR is the complete, self-contained story of the transaction, and packaging it up like this is what allows the whole system to be decentralized and trustless. This brings us to a field that is so easy to just ignore, but it can literally be the most critical piece of information in your entire transaction. This is especially true when you're dealing with big platforms like exchanges. I'm talking about the memo. I mean, just think about it from an exchange's point of view for a second. They might have one main deposit address for Pi, but they have thousands, maybe hundreds of thousands of users sending Pi to that one address every day. So how on earth do they know that the 199.99 Pi that just landed belongs to you and not somebody else? The answer is the memo. Honestly, the best way to think about it is like the attention to line on a letter you're sending to a giant office building. The building has one street address, right? But the memo tells the mailroom exactly which person in which office gets the package. Without it, your funds are just lost somewhere in that massive building. So let's walk through this, because getting this right is just vital. When you go to deposit, an exchange is going to give you two pieces of info, the address and your personal unique memo. You have to use both. And as you can see right here, step 4 is the one, it's the make or break moment. You have to copy and paste that memo into the memo field. It is absolutely essential. And I really cannot stress this enough. Forgetting the memo is one of the most common ways people lose their crypto, period. If you send your Pi to an exchange's address without that unique ID, they have absolutely no way of knowing it belongs to you. And in a lot of cases, those funds are just gone for good. Okay, for our final layer, let's zoom out and look at what holds all of this together and keeps it secure. We'll also touch on that really critical balance between transparency and privacy. Every single transaction is sealed with what's called a digital signature. The best way to think about this is like an unforgeable digital wax seal. It's created using your private key, which is something only you have, and it's mathematically tied to the specific details of that one transaction. And that digital seal gives you two rock-solid guarantees. First, authenticity. It proves that you and only you could have authorized this payment. And second, integrity. It proves that the details, like the amount or the destination address, weren't messed with after you sent it. In short, it proves it's from you and it's exactly what you intended to send. So this brings us to this really fascinating balancing act between transparency and privacy. See, by design, a blockchain is transparent. Anyone can look up this transaction. But features like those muxed addresses we talked about earlier, they provide a certain layer of privacy. While the whole world can see funds went to the main exchange address, that bundled up sub-account ID keeps your specific account within that exchange just a little more private. So all this leaves us with a final thought to chew on. We've seen how every single piece of a transaction is designed for security, efficiency, and transparency. But as we move into a world that's built on these public ledgers, it kind of forces us to rethink our old definitions. In a system built on open and verifiable trust, what does the future of your privacy and your digital identity truly look like? It's a huge question, and it's one we're all going to be answering together.